Hey team, welcome back. This is video 14, and it is about basically three functions in RStudio. So these are the functions that you can use in order to visualize variables or relationships between variables, which I find to be a really useful thing to do when I'm just sort of thinking about what's in the data, like really just what is there. A visualization can be super helpful. So I'm just going to show you two functions that I use with single variables, and one function, which you've actually already seen, that I use to compare values on two variables. All right, so I've got RStudio open. You might want to open it yourself. You should check that your current working directory is, in fact, psci232. It is. I'm actually gonna do all of this in the console today. So you should be able to follow along just kind of line by line. As a reminder, if you're not able to follow along line by line, or something goes wrong or weird, definitely stop the video, write down a question for me, go back, see what you can. Oh, I'm welcome. I don't know what that's about. Anyway, I've gotten a lot of glimpses into my life recently. Yeah. All right, so here's what we're going to do. I'm going to first start the way I usually start by saying library tidyverse, because I want to read the county's data. I'm just going to think about it for a second. There we go. Then I'm going to do cnty gets read underscore CSV. And because I'm already in my psci232, yes. So you can see that I just did CO tab. It knew what I was looking for. That's all I need. There it is. So here is, I'm just going to type cnty to see kind of what's there. And again, this is the usual thing that we see. We see a state name, a county name, a state, a county, a total population, et cetera, all the way down to a variety of, all the way down to a variety of measures of life in each county in the United States. So what I want to talk to you about is kind of what plotting functions. So plotting means any kind of graphical representation of, I'm going to make this bigger. Plotting is any graphical representation of your data. And you should be using a plot that makes sense for the kind of data that you have. So for example, if I want to do, I just want to make sure, cnty rural, nope, that's not it. So rural, as you can see here, is a continuous variable that takes values from 0 to 1. I want to sort of work with first functions for visualizing variables that are either that are ordinal or categorical. So to do that, I need to find an ordinal or categorical variable to use as my example. And in fact, let's see, so table rural, cnty $, rural urban continuum code. That's it. That's what I want. All right. So there are 9 values in the rural urban continuum code. And that is an acceptable number of values to put on the first thing we're gonna look at, which is a bar chart or bar plot or bar graph. Bars is the thing. Bar plot is the function you're going to use, and bar plot takes a table as an argument. So typically when we want to create a bar plot, we use nested functions. So I'm going to say bar plot table cnty rural urban continuum code 2013. So you can see that I did table. That's this thing we did just a moment ago. And then in addition to that, I kind of wrapped it in this bar plot command. And if we're, there we go. It's thinking for a long time. And there is a bar plot, right? So this is not a wildly useful bar plot. It tells us that there aren't that many counties in the United States that have this sort of middle classification, 4 and 5. Yeah, it's not that interesting. Let's see, what else can we use? We can also do a bar plot for, let's say, something like, this is going to be a ridiculous looking bar plot, and I'll show you why in a moment. So again, bar plot, table, CNTY. I'm going to give it the state names. Can you envision in your head what that bar plot is going to look like? This is going to be a bar plot of how many counties are in each state. And it looks redonkulous. And the reason it looks crazy is that we can't actually see all the labels. But basically what you're looking at is how many counties are there in each state. And that is going, you can see the x-axis goes from Alabama to Tennessee, well, actually, probably, presumably to Wyoming. And there are a lot of ways to kind of fix those axes so that you can see each state. But I think the point here is to just say, oh, look, you can do that. And you can do that with one line of code. So that's bar plot. Bar plot just takes, again, a table of a single variable. And next, I want to talk about two plots that you can use with count or continuous variables. So I'm actually going to go back to that. I'm going to go back to the variable CNTY rural, which, as you remember, takes values between 0 and 1. I want to look at it. So there are 7 NAs. That's a pretty acceptable number in the context of a data set with 3,143 observations. Minimum is 0. That is to say, nobody lives in a rural area in that county. Maximum is 1, which is to say everybody in that county is living in a rural area. That makes perfect sense. And you can see some of the other stats there too. The first thing I want to do is try this, hist. CNTY rural. So hist is the function for a histogram. And we get that. So what does that say to us? On the x-axis, a histogram shows us how many, it kind of takes a variable and it breaks it into categories. So in this case, we can see that the categories are 0 to 0.1, 0.1 to 0.2, 0.2 to 0.3, etc. And then it shows you how many cases are in each category. And a thing that I think is interesting here is that the category with sort of 90 to 100% rural is by far the largest category. I actually find that really fascinating. So what I want to do is I want to show you some options that you can do with histogram. Probably the most important one. So we're going to give it the same basic command, hist, parenthesis, county, $ rural. This time we're going to go comma, breaks equal to 19. Because here in this one, we've got 1, 2, 3, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you've got 10 categories, then there are 9 breaks, but I want 20 categories and consequently 19 breaks. As you can see, what happened there was that it just broke up into smaller increments. We could do something wacky like 100 breaks, and then you would get this crazy thing. So there are a lot of counties that are 100% rural. There are the next largest category, as you can see, is counties that are 100% urban or 0% rural. And then everything else is fairly evenly distributed, right? So that's histogram. And again, a histogram shows you the rough distribution of shows you the rough distribution of a variable across all of its possible values. So for example, if I were to create, let's make another random normal distribution. We're going to call it X. We're going to give it a mean of 5 and a standard deviation of, I don't know, 25. Sure. So if I want to say hist of X, that shows me a nice normal distribution. I could say hist of X and ask for more breaks. I would get something like that. So histograms are useful because they can show us kind of, okay, what neighborhood of values is most common? Are there, what neighborhood of values is most common? Are there values that stick out weirdly? In this case, no, it just looks pretty much like a random normal distribution. The other way that we can use, that we can look at a count or continuous variable is with a box plot. So some of you might remember a box plot from high school or even middle school or elementary school, and it looks kind of like this. Box plot, X. So there's X. And basically in a box plot, the line in the middle is your, the line in the middle is the mean, and the bottom and top of the box are the bottom and top of the box, golly Amelia, are the kind of center of the distribution. The top and bottom of the box, or the top lines, and it goes dot, 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 top line shows, roughly speaking, the 95th percentile and the 5th percentile. And then the individual dots on the very top and very bottom are what we call outliers. I don't love box plots. Maybe they feel really useful to you. They can be really useful when you're, for example, comparing two distributions. So if we were to make a distribution called Y, we'll give it, it's going to be 500 values long, and it's going to have a mean of 10 and a standard deviation of 10. Now I want to do side-by-side box plots. That's what they look like. So number 1 there is X and number 2 is Y. And what that shows you, roughly speaking, is that X is a much wider distribution, but with a somewhat lower mean. And that is exactly how we designed it. So good. Let's finish by doing a box plot, not a blocks plot, a box plot of our rural. Yeah, there it is. No outliers. The mean is approximately 0.6. It looks like it's skewed kind of upward. There are more values on the top end than the bottom end, but we know that because we saw that big spike at 100% rural. So that is how you use a box plot, or how you create a box plot. I typically prefer a histogram myself, but you know, to each his or her own, or their own. Finally, I want to show you one more time how to make a scatter plot. And a scatter plot is going to be any plot that compares two variables. In this particular case, I'm going to say plot CNTY top pop. Ooh, no, how about total votes? That'll be fun. Total votes is somewhat, actually, let's do it this way. This is a more fun idea. CNTY, top pop, comma, CNTY, total votes. So we're now going to look at the relationship between the total population in the county and the total votes in that county. Take a minute, think about what you expect to see. If there's more population, there should be, that's right, more votes. So it looks like that. Yup, that's it. You can see that there's sort of there's like a roughly straight line with a couple of crazy outliers. That's the one in the very top right is probably Los Angeles County. Contains the city and county of Los Angeles are coterminous and enormous. But you could also use a plot like that to kind of think about like, oh, well, there are a few counties that seem to have really high voting rates. That is to say their population is, their population, their total votes is a little higher than you would expect from their population. So like I'm thinking of, if you can follow my mouse, I'm thinking of these here. They seem to be above the line. This one seems above the line a bit. And there are also ones that are a little below the line, right? So here's a population line. There's a fairly wide variation there for how many votes there are. Let's look at another one. I want to try CNTY top pop, comma, CNTY per underscore dem. So this is going to help us look at the hypothesis that Democrats live in cities, which is by and large a fairly accurate thing to say in the United States, for better and for worse. Again, we have kind of a problem with the fact that there are huge outliers on total population. One way of dealing with that is to take the log, and you don't really need to understand what it means to take the log, just know that it kind of diminishes large distances. So we could go plot log CNTY top pop, comma, CNTY $ per underscore dem. And that should give us a kind of easier to look at picture. So that looks like that. And you can see that these are counties with much higher population. And as we would kind of expect based on that naive hypothesis, yeah, those counties with higher population do seem to be experiencing more Democratic voting. So again, just for those of you who want a quick review, when you look at a scatter plot, you're looking at where each observation lies with respect to two variables. So for example, here we see that there's really high variation when the log of your total population is about 10. And that is to say when your population is about 22,000. So there's a lot of counties with about 22,000 people, and they vary from this one down here that voted under 10% for Hillary Clinton to this one up here that voted 85% for Hillary Clinton. So a lot of variation. Over here, this one way out on the end is going to be our friend Los Angeles County, which has roughly 8.88 million people, voted around 70% for Hillary Clinton. If the log scale is throwing you off here, please don't be afraid. It's just a way of making it easier to look at this stuff. Feel free to ask me questions about it. For now, that's it, and we'll talk more about this in class.